So today, inshallah, we are going to know more about the buildup of electrons in shells and understand the significance of the noble gas configuration. Okay, so this is actually what we're gonna do. The thing on the right, we're gonna do electronic configuration of different elements for different atoms. And we are going to be able to relate this electronic configuration to the position of the element in the periodic table. We will also know or understand how electrons determine the chemical properties of the elements and how the elements form compounds. So let's start together. So first of all, to do an electronic configuration is to arrange electrons in shells. We know that an atom is formed out of a nucleus, and we have a number of shells around the nucleus in which electrons are orbiting the nucleus. So you can look at shells as like in a circus where the first row can take up to a certain number of chairs, the second can take more number of chairs, and the third can take more and more number of chairs. So this is actually what happens with electrons, that every shell has a certain capacity for a certain number of electrons. So for instance, the first electron shell around the nucleus holds only 2 electrons. It cannot hold more than 2 electrons. The second shell can hold up to 8 electrons. So if you have 8 electrons, you can put them in this second shell, after of course filling the first one with 2. And we will see more about this in the upcoming slides. As for the third shell, it holds up to 8 electrons. This is not actually what it can hold. It can hold more. It can hold up to 18 electrons. But for the time being, we will be able to put only 8 electrons in this shell. So in order for us to work out this electronic configuration of the 20 elements, we need to just download the sheet from the website. You will find this sheet in the website. You can download it, or if you cannot download it, just freeze this video and try to solve it and return back when you have done it to see what exactly we're expected to do. So what you need to do here is to draw the electronic structure or the electronic configuration for these 20 elements of the periodic table, and one has been done for you as an example, which is for the element neon. We have said before that next to the element symbol you will find 2 numbers. One is the atomic number, which represents the number of protons, and the other one represents both the number of protons and the number of neutrons added together. So what you're going to use here is the atomic number, of course, because also we have said before that for an atom to be neutral, the number of positive protons should be equal to the number of negative electrons. So you can take the number of electrons for any atom from the number of protons of this atom. For instance, for neon, you have 10 protons, so you must have also 10 electrons if the atom is neutral. And since the atom in front of you does not carry any charge, and because it is listed in the periodic table, this means that the number of protons will be equal to the number of electrons. So for neon, we have 10 electrons equal to the number of protons, which is also 10 protons. So we have to distribute these electrons in shells. So the first shell, as we said before, it can take only 2. So we are going to put 2 of these 10 electrons in the first shell, and for the second shell it can take up to 8, and actually we have a total of 10. We have already placed 2 in the first shell, then we can place the remaining 8 in the second shell. I'm gonna do 2 of these examples with you right now. You have to pause the video and you can try to do the rest of the 20 elements on your own, and when we return back I will show you all the 20 elements when they are done. Okay, so let's check. For instance, let's take one of the elements from the left side of the periodic table and one of the elements on the right side of the periodic table. So let's see. So we can start doing, مثلا, for instance, we can do sodium. Okay, let's do sodium, and sodium contains 11 protons. Then we need to distribute 11 electrons as well. So the first shell will take only 2 electrons. So here are our 2 electrons in the first shell, and we are left with 9 electrons from the 11. So 9 electrons cannot fit into the second shell because it can only hold 8 electrons, and that's why we are going to put 8 electrons in the second shell, and then the rest of the electrons we will be putting those in the last shell. So we were doing sodium, and we said that sodium has 11 electrons, and we said that we're gonna be putting electrons here. We're gonna be putting 8 electrons in the second shell. Now we are done with 10 electrons. We're done with 10 electrons, and it is 1 electron that is left. So we're gonna put this 1 electron in the last shell. So as you can see, the electronic configuration of sodium will be 2, 8, 1. 2 for the first shell, 8 for the second, and 1 for the last shell. Let's do one from this side, and let's do sulfur. So sulfur has 16 protons. And of course, since protons are equal to the number of electrons in neutral atoms, then we have 16 electrons in a sulfur atom. Let's get them distributed in shells. We're gonna do 2 in the first shell, 8 in the second. Now we're done with 10, and 16 minus 10, that's a 6. 6 electrons are left. We're gonna put these 6 electrons here because this layer, this shell, the third one, can hold up to 8. So now we write the electronic configuration as 2, 8, and 6. Let's do the last one, which is gonna be calcium, and calcium has 20 protons, meaning that it has also 20 electrons. Let's get these electrons distributed without drawing these dots. So the first shell can take up to 2, and the second can take up to 8. Now we're done with 10 electrons of the 20. The third can take also up to 8 only. So now we're done with 18, and 2 electrons are left. We're gonna put these 2 electrons in the fourth shell, and the electronic configuration of calcium will be 2, 8, 8, 2. Now I want you to do the rest of the elements. So you're gonna do the rest of the elements. Let's return back to where we were. Okay, let's return back to where we were. And okay, and again, previous, yes. So we're gonna do this. You're gonna do the rest of the elements, and you're gonna pause the video, and when you return back, I will show you the electronic configuration of all the 20 elements of the periodic table. And we're back, and this is a table that shows you the electronic configuration of all the elements in the periodic table. Okay, so you can just freeze this screen and see if you have done it correctly, or you can just take a look at this electronic these elements and their electronic configuration here also. Like for instance, potassium is 2881. Here lithium is 21. If you have done it correctly, then you're on the correct track. I just want to mention something here, that when we're taking the 20 first elements of the periodic table, this is the location of these elements. So you can see that you have this one, and it starts with 1 proton, then helium 2 protons, 3, 4, 5, 6, 7, 8, 9, and 10, and then 11, 12 till 18, and then we have 19 and 20. Okay, so as you can see, the periodic table is arranged according to the atomic number. So all the elements are arranged according to their atomic number. And the periodic table is formed out of columns, and we will call these columns groups. And we have rows, and we will call these rows periods. There is also one important note here, is that after the element calcium, you will find that you have a block here, which is the block that is responsible, or that carries the transition metal symbols. Okay, so here we have, in this block, we have the transition metals here, and you have 10 groups here. 10 groups. So you have group 1, group 2, and then you have 10 groups, and then you have group 13, group 14, 15, 16, 17, and the last group in the periodic table is group 18, and that's how we name the columns. The columns in the periodic table are named groups, and we have 18 groups in the periodic table. Okay, so let me show you what you have done so far. So as you can see, these are the electronic configurations of the first 20 elements of the periodic table, and don't forget that we have the transition metals in this location. Okay, so please correct it, and if you have done anything wrong, or if you have any question, you can just send me your question, and whenever I'm free, I will respond to the question and answer it. So let's stop at this point for this video, and let's continue next time, inshallah. See you soon.